Okay, in these examples, just want to look at some SVA questions, some variable acceleration questions, where the acceleration or the displacement or velocity is written as a function of time, but they're also in component forms in terms of i's, j's, and maybe k's as well. But it's the same principle that when we have s, v, and a, we're going to differentiate to go down from differentiate s with respect to t, so r, w, r, t with respect to t. And when we're going upwards, we're going to a to v to s, we're going to integrate with respect to t. And always remember, when we're doing that, you have to add a constant of integration when you're integrating. Fairly straightforward when it's written in component form. Here we're asked to find the speed of p when t equals 4. Now we're given that v is equal to 2ti minus 3t squared j. Now I know to get speed, well that's based on velocity. So when t equals 4, the velocity equals, that becomes 2t is 8i minus, well, 4 squared is 16 minus 3 is minus 48j. But speed is just the magnitude of velocity. So to get the speed, it's the square root of 8 squared plus 48 squared. When we put that into our calculators, the root of 8 squared plus 48 squared, and that's 48.7 meters per second to 3 significant figures. Okay. Essentially what we're saying is it's going across by 8 and down by 48. So we want the magnitude or the resultant of that. We find that and we use Pythagoras' theorem to do that. Part B, the acceleration of p when t equals 4. Well, again, let's start with velocity. It's 2ti minus 3t squared j. I know if I have velocity, I differentiate to get acceleration. So acceleration, we differentiate the I component. So 2t differentiates to give 2, so it's 2i. We differentiate the j component. Minus 3t squared differentiates to give minus 6t, and that's still j. And that's our answer. The acceleration, we're not asked for the magnitude of it, we can leave it in terms of i's and j's. Excuse me. Final part here, part C. Given that p is at the point with position vector minus 4i plus j when t is 1, find the position vector of p when t equals 4. Now, what we're saying here is that when t is 1, the displacement is minus 4i plus j. So let's use that boundary condition to help us find an equation for displacement. I know that I integrate velocity to get displacement. So v is 2ti minus 3t squared j. So when I integrate 2t, I get t squared I. When I integrate 3t squared, I get minus t cubed j. But because I'm integrating, I have to have a constant of integration. Always when we're integrating in these questions, a constant of integration. Now let's use our boundary conditions. When t is 1, s is minus 4i plus j. So minus 4i plus j is equal to, well, 1i minus 1j plus c. And when we rearrange that, then we can see that c is minus 5i plus 2j. Now, we can either tag that on at the end, so we've got s is equal to t squared I minus t cubed j minus 5i plus 2j. That's absolutely fine. Often you'll see it written, and it's quite handy to bring all the I components together. Say that's t squared minus 5I plus 2 minus t cubed j. You see, this is much handier writing like that if we have it like that and want to differentiate to get velocity or acceleration. Although in this case we don't need to do that. All that we now need to do is say when t equals 4, what's the position vector? Well, displacement then is 4 squared is 16 minus 5 is 11I. Oops. And 2 minus 4 cubed, 2 minus 64, which is minus 62j. And we can leave it like that. Second example. More of the same. So just quickly run through this. This time we're starting with displacement. It says show P starts its motion. So in other words, when it starts at t equals 0. So let's put that in. So part 1. S is equal to t squared plus 2I plus t cubed minus 1j plus t squared plus 2t. Okay, and you see we're in 3 dimensions here. But when t equals 0, S is equal to 2I minus j, and there's no k. In other words, the k component, no k component, and that implies that we're in the ij plane. Part 2, find a speed. Now again, a couple of things here. We're not asked for velocity, we're asked for speed. But the first thing we need to find is velocity. And I know that velocity is what we get when we differentiate the displacement. So let's differentiate the I components, we get 2ti. When I differentiate the j components, I get plus 3t squared j. And when I differentiate the k components, I get 2t plus 2k. Now, when t equals 2, the velocity is 4I plus 3 times 4, which is 12j, plus 4 plus 2 is 6k. So we've got that in terms of velocity, but we're asked for the speed, which is the magnitude of that, which is just the square root of 4 squared plus 12 squared plus 6 squared. And again, when we put that into our calculators, root of 16 plus 144 plus 36 is 14 meters per second. Finally, part 3. Find t when the acceleration is given like that. Well, again, we know acceleration is what we get when we differentiate velocity. So here's our velocity. When I differentiate that again, I get 2I plus 6tj. And when we differentiate this, we get 2k. Now, whenever that's equal to this, let's see what happens. 2I plus 8j plus 2k equals 2I plus 6tj plus 2k. And you see then that it's only the j components that are slightly different. So we see that 8j is equal to 6tj. 6t equals 8. And so the time is equal to 8 divided by 6, or 4/3. And last example. This time it's moving. We've given the acceleration here. And a boundary condition here. So acceleration, find the velocity of t seconds. So we want to start with the acceleration. 3t squared plus 4ti plus 6t minus 5j. So we're going to integrate this to get our velocity. So we're going to get, when I integrate that, we get t cubed. When I integrate 4t, I get 2t squared I. And for the j components, when I integrate 6t, I get 3t squared and minus 5t j. One thing I must put at the end, though, is my constant of integration. It doesn't matter if I put it, it's much easier to put there at the end, I think, rather than a plus c and a plus d here. But now, we were given a boundary condition here. So when t equals 3, then the velocity was 48I plus 10j. So let's put that in. 48I plus 10j is equal to, when t is 3, that's 27 plus 18, so that's 45I. Plus, when t is 3, that's a 9, 27, take away 15. So 27 take away 15 is 12j plus c. And again, we can see here that c must be then 3I minus 2j. And so the velocity, let's just finish that off then, is, in terms of our i's, we've our t cubed plus 2t squared, and then I've got an extra 3 here, I, plus 3t squared minus 5t, and I've got minus 2j, so minus 2 j's. And there's my answer for part 1. Finally, find the speed. Again, just be careful, we're looking for speed here, not velocity. When it's moving parallel to the vector I, if it's moving parallel to the vector I, there must be no j component. The j component equals 0. So what I can say here is, in our velocity, the j component equals 0. So 3t squared minus 5t minus 2 equals 0. That's the j component of this. I can factorize that. My 2. So once we factorize that, we see that t was equal to minus a third, or t equals 2. But because you can't go back in time, we can't have minus a third as a time, so it's not appropriate. So whenever t is 2 seconds, what is our velocity? Well, the velocity is, when we plug it back into here, we get 19I plus 0j, and we expected that to be 0j. But again, we're not asked for the velocity, we're asked for the speed. The speed is the magnitude of the velocity. Well, the magnitude of 19I is just 19. So we give it an answer, final answer is 19 meters per second.